Hello, welcome back to Blender Sushi. In this episode, I'm gonna talk about a math function called greater than, and I will be demonstrating it using Blender cycles. And in the future, I will try to demonstrate the same thing using Sphere Chalk add-on. But for now, it's gonna be just using cycles. Um, so yeah, let's get started. So I will need to use cycles, and then I need some kind of object, and I will need to give it a material. So it's going to be cycle material, create new. So that's the default cycle material. If we render it out, it's going to be white color, diffuse material. Let me save first. So this is cycles greater than. So greater than math function is a fairly basic, but oftentimes we don't think about how to use this math. So in cycles, you have math and vector math. I think greater than actually in here, math. And that's the function that we're going to be talking about. There are other like modulo that's kind of interesting for repeating pattern, but we're going to be focusing on greater than. So let's see how we are able to see something like this. So let's say we just plug it in, and instead of diffuse, maybe I will just be using emission. So it's gonna be full color. Gonna delete that, and let's render this out. So by default, greater than seems to be giving a black color. Let's see if we change the value and whether you can see the difference. So the value, the first value compared to the second value is 1.5 greater than 0.9, and that's actually true. So that's why we are getting white. So this is actually what's happening when you're playing around with the number. You can see you can turn on and off, or getting a true or false color that you can pass down as a color. So that's kind of interesting, right? Because let's say we are using noise texture and plug this into that guy. By default, noise is giving us this random color of noise. They are like nicely gradated from one color to another. If we are plugging the vector, we are getting some kind of grayscale, like a cloud looking texture. But let's imagine if all this color is actually a value. So the value, let's say, imagine if they are normalized between 0 and 1, 0 being black, fully black, and 1 being fully white. This cloud noise color is actually in between 0 and 1, I believe. So if we plug this vector into greater than, we can, let's see what's gonna happen. If I scrub between 0 and 1, you will see that suddenly our noise, our grayscale cloudy noise, become just very strong white and black. There's like a strong diffusions. There is no gradations whatsoever between the two. And this is actually very, very interesting. We can use this to do some kind of masking. We can also do it to kind of like giving an either or. For example, if I'm using mixed RGB, that means we're gonna mix two color. And if I'm using red and blue, or red and yellow, and plug in this value into the vector, we're gonna see that we can have the two color. It's not like really blending, but you can sort of morph from one color to another this way, thanks to the greater than math expressions. And this can be really powerful, and I'm still actually studying this. And let me try using other. I think mix is okay for now. I'm not gonna play around with that too much. But this guy, we can also use to mix a shader. So let's say instead of emission, um, let me unplug that, and I'm gonna create transparent shader, and I will be using mix shader to mix the emissions and transparent, and plug this result of noise and greater than into the mix shader, and let's see what we're gonna get. So you can sort of see the transparent BSDF at a full white color will give us this transparency, of course. But the one that's emission, this guy is fully opaque. And then, so instead of emission, maybe I'm using diffuse. Plug that in, and with the diffuse, I'll give it a color. And let's turn on the environment light with a. We don't need ambient occlusion in this case. Just a diffuse, and you can see the transparency. So whenever, if I try, let me use emission once again. So there is a mix RGB here, plug into the emissions. I'm gonna interchange between these two. So you can see the one that's red is around here. Let me plug that in. So the one that's red, or the one that's fully diffuse, I think that's actually the white color. Let me check real quick. Okay, the one that's black color, it's gonna be red. That's mean the one that's darker color, or like 0, is gonna be opaque. So the white color one, of course, gonna be replaced by this transparent BSDF. So based on this noise alone, we can create a very interesting result. And this happens at render time. And at any point in time, I can actually play around with the noise, animating it using something like animation nodes. See, increasing the detail or decreasing the detail, and you can see the effects in real time. You can also distort it to get more like wild kind of result. And I mentioned about animation nodes because if you go to animation nodes and then find a cycles material output, let me select that material, and then I'm gonna grab let me animate maybe just the greater than. So the math node, it has 2 values. The second one can be animated using animation nodes. Let me try. So if I'm not wrong, this is actually possible, but sometimes with animation nodes, this you can't see it happening in real time unless I'm using a value here. If I'm not wrong, float value. So we are using a value node. We should call it something, but for now, I'm just gonna target this node using animation nodes, value nodes, and then it says no animatable input. Well, that's interesting. Vector combine XYZ. Let me try this actually. Well, okay, let's pretend that we're gonna be animating this combine XYZ using animation nodes, and you can see this is actually working. So there's a XYZ data, and let's see if I'm just animating the X. So it's still kind of a quick hack, but you can see if I'm using the combine XYZ, it is working. If I'm using greater than, it doesn't work. So maybe it's a little bit of bugs. But anyhow, you can animate this in real time and then you can render it out. So it's very cool. So that's if you want to use animation nodes. Let's get back to this guy. Imagine if this object is not just a single flat layer of surface. Let's say we are using solidify. Let's solidify this guy a little bit. We're gonna have, of course, 2 layers of surface, right? It is still kind of flat. If you look at it from cycles perspective, this guy is gonna be just flat objects. If I render this out, you will see there are two pieces layer, and then each one is getting noise at different point, I believe. To be really sure, I will actually use the texture mapping, I think texture coordinates from these objects. Let me try generate it, or maybe object. Yeah, I think probably object is better. So we have 2 layers and each one of them is getting this shader. Let's try now using another solidify and check how many layers we have now. Go to wireframe, play around with the thickness, and we should see 1, 2, 3, 4. Okay, let's do another one. Actually, before I do another one, just leave it as it is now and render it out. So we should see that we have 4 different layers. Each one of them should be getting a different noise. And of course, this is happening in render time. My idea is to use this kind of setup and try to bake it out so I can render it, or I can kind of remesh it as a real mesh, 3D mesh objects using the help of Spreadchalk add-on. That's gonna be for the next one. But this kind of magical looking result is simply based on greater than. Okay, it's just a simple math function or math expression to check whether the value is bigger or smaller than the other value, can give us something that's quite sophisticated looking. Okay, let me do one more. You will see if I do another solidify and then check the wireframe. This should give us another layer. Now we have how many? 6 or 12? I think 6 layer. If I render this out, suddenly it becomes black. You might be surprised. Why is that black? Because we need to take care of this guy right here. Light path. How by default it says 8. We actually want this to be higher, I believe, in order to be able to render the transparency. There you go. As after I go over 16, this actually works. So now let's look at it closely. So this is Cycles material doing its magic, basically kind of doing a volumetric effects. So for every flat layer of surface based on box and material solidify, we can see how the noise actually works in 3D. So this is kind of interesting, and I'm gonna try to make a similar setup in Spreadchalk and kind of connecting cycles into Spreadchalk, so we can use the noise here to generate an actual 3D objects that can be printed. So yeah, so that's the whole idea. I think that's kind of interesting. And before I learn about all these procedural ways of things, I rarely rarely look at this function greater than. For me, it was kind of abstract, kind of complicated. But now it makes sense, because if you compare 2 values, you can tell whether it's true or false. If it's true, it's white. If it's false, it's black. whatever in between is going to be grayscale. So if we plug in the noise, whatever noise it is, whether it's in the normal cloud noise, or if we are using like a Voronoi, let's try Voronoi, you will see a different result. See, by default, Voronoi is actually giving like a circular kind of result, which is kind of interesting in itself. Try doing this like using maybe modulo functions. You're gonna get quite interesting result. Try cell. Cell is gonna give you like kind of a cell-like pattern. Not as interesting as the noise, but still something you can use. And the nice thing about cycles, of course, you can mix things. And if you want to use another math function like a multiply, I think add, subtract, multiply, this will you can basically mix and match a color. Like if you don't know what it does, just try, let's say, multiply, and then you mix the noise and Voronoi together. Check the result. Okay, let's see whether we can get something interesting out of this. By default, nothing too interesting, but until I change to add. Now this Voronoi is mixing with our noise, and we are getting pretty interesting result, and everything is real time. And yeah, I think that's kind of interesting. You get a lot of dots and also noise. Maybe decrease the noise, decrease the detail to 0. Distortion, maybe increase it, so you can get something like that as well. It looks like works by Yayoi Kusama. It's one of Japanese artists that's actually kind of obsessed with the dots. But anyhow, we don't need to go that far. Just back to the basic. So play around with this idea first. Use like a multiple solidify and see how many, what kind of interesting shapes you can get out of this. It looks like 3D because this is like, it's doing its thing at render time. You can't just convert this into mesh. And then I think I'm trying to do that using Spherechalk add-on next. So let's see how it goes, how I can transfer this into a mesh. So thanks again for tuning in on this one, and I'll see you next time. Thank you. Bye.